as you can see, the definition of parabola is locus of all equidistant from the focus. That distance is exactly the same as that distance to the directrix. Now, easiest way to see it is right there. You see that they're exactly same distance away. And the other place is right there, right? 2 units, 2 units. And then here's another place. Do you see there is this distance is 5. And do you see this is 5? 3, 4, 5. So if you collect all of these, then this will give you a parabola. I kind of learned about it in algebra 2 and forgot about it, right? Because it didn't have really significant meaning at that point, right? Okay, I'm gonna put this in the notes. Okay. This is where we start. Say this location of this is 0, p. For some reason they use p when it comes to parabola and everything else is c. I don't know why that is. And then equation of the directrix is y is equal to negative p. Okay? What that means is this distance right here is p, and this is right here is p as well. Okay? I set it up to be 1, but in general it's p. And then we'll call this x and y, the coordinate point. Okay? Then by the definition, this is a congruent line to this, so I'm going to call this d1 and I'm going to call this d2. Now, so by definition, d1 is equal to d2. Okay, distance formula now, square root. So d1 is x minus 0 squared plus y minus p squared. And the other side is x minus x. Oh, what's the coordinate here? Is it x and negative p? Y'all agree? So x minus x squared plus y plus p squared. I'm going to square both sides, so, and square that thing is inside. And that's 0, so we have y squared plus 2py plus p squared. Let's see what cancels. Y squared cancels. P squared cancels. So what we have left is x squared is equal to 4py. You remember this ridiculous looking thing in algebra 2? Now, why would they do such a thing? I have no idea why all the books do it in conics like this. But most sane people, and which is us, ugly writing. Most sane people will do it like this, right? Now, and that's of course our usual. Now, comparing these two kind of tells you a very important formula. A is equal to 1 over 4p. And that's kind of all you need to know, which is same thing as saying p is equal to 1 over 4a, which is really same thing as saying 4ap is equal to 1. I mean, pick the one, whichever one you want, or whatever is convenient at the time. So far, so good. How do you like it? So let's review. We started with just the definition, and then we arrived at exactly those formulas that you're taught in algebra 2. Do you have time for ellipses? Yeah, let's do ellipses. Okay. I need to open this. Go up, algebra 2, ellipses here. Now, the definition of ellipses is there are two foci, and they are pronounced foci, not foci. And then the sum of these two strings is exactly same as from here to there. Okay, so I'm gonna save this picture. So let's see. For the convenience, we're going to set this thingy A. A is from here to there. Okay. And this thingy is C. Okay. So this is coordinate of this is of course is negative C 0 then, and this one is C comma 0A. And like before, we're going to call this X comma Y. How about that? You get this set up? Now, first thing we have to understand is why is this thing, the sum of this same as the major axis? Okay, that we have to go back here. Watch this. This is a really good place to see. So distance, that distance right here, all of that, and then that much is missing, but then it goes back that side. You see why this whole thing, sum of the two has to be exactly same? And then, whoa. The other place that is important to see is right there. In this particular ellipse, you see 3, 4, 5. So this length is 5 and that length is 5, isn't it? Okay, so that you have to understand. And this is a very important picture, which like if I run out of time, remind me to talk about this tomorrow. But so I'm going to call this D1 and this D2. And we'll say by the definition D1 plus D2 has to be same as 2A, major axis from here to here. So half of it is there. You can call it A and still do it, but algebra gets tougher. So DA for the convenience. So D1, of course, is square root of x plus c squared plus y squared A. And then D2 is x plus x minus c plus y squared A. And then that is equal to 2A. So far with me? Now we have to, if you square this side, you learned in algebra 2, you cannot really square both sides and that becomes crazy. So we have to send one over to the other side. So let's do this. And then we'll square both sides, okay? So this becomes x squared plus 2c. I'm going to do a little faster. And then this is 4a squared minus 4a square root of x minus c squared plus y squared, scrolling a little bit, and then plus squaring that thing inside. With me? Let's cancel. This thing cancels that thingy, this thing cancels this thingy, this thing cancels this thingy, right? Okay, I'm gonna move the square root to the left, and then everything else I'm gonna leave it. So 4a square root of x minus c squared plus y squared is equal to 4a squared here, and then minus 4cx. Too much algebra? You follow? Divide both sides by 4a, so I have x minus c squared plus y squared is equal to a minus c over a, right? X. Still with me? Okay, now I square both sides. So this thing is x squared minus 2cx plus c squared plus y squared is equal to a squared minus 2cx. Too much algebra, right? Please tell me that's not too much algebra. And some of you are worried, but be rest assured, these two cancel. Ah, you were worried just a little bit now, right? Bring this thing over. So, and common factor it here. So what we have is a squared minus c squared over a squared x squared. Too much algebra? Little bit of fraction addition there. And then divide everything by this thingy. So we have x squared over a squared plus y squared over a squared minus c squared is equal to 1. Oh, final step. We let b squared equal to be a squared minus c squared. Substitute. Then we have voila. Oh my God, that is amazing, isn't it? More importantly, this is the thingy that matters more. A squared is equal to b squared plus c squared. That looks like Pythagorean theorem now, doesn't it? Right? Let's quickly go back and look at this picture. This picture I'm gonna save, and then we'll call it a day. Okay, if we have this picture, let's just think about which is which. This was A, remember, and this was C, and this was A again, isn't it? Now let's think about the intercepts. Intercept, x-intercept is when y is equal to 0, so that tells you x is equal to plus or minus A. So this is A, as we kind of figured out geometrically. And then y-intercept when x is equal to 0. So that tells you y is equal to plus or minus b. That tells you this is b and this is negative b, eh? Which tells you this distance right there is b. And then you have that Pythagorean theorem you see right here, that much. And that happens to be the distance between these two vertices. Okay. Now, having said that, let's get to picture that is little. Okay, so it's exactly the same picture, except, right? This thingy minus that thingy has to be exactly this much, the distance between the two vertices. Okay. What was the name for this in pre-calc? Transversal axis, was it? I'm not good with names, but something like that. Now
major
we have
axis,
to.
I think.
Oh, transverse what?
I think it was major and minor axis, but I might be
That's the
mistaking that
ellipse.
with ellipse.
Yeah, that's an ellipse. This thing goes side, whatever. It's not like I'm gonna put vocab on your test, right? You already know what your test is, so hey, not to worry. You don't have to know this name, but let's think about it. Okay, that distance, right? Minus that distance takes away that much, so you see why it has to be exactly fitting between the two vertices. This is a good place to look at it. This distance minus that distance, you get it? Do not want to do that. See, it's like slightly above all of this minus all of that, so it takes that part away. You get it? So the distance between the two is the difference, and we'll call this A and an A. So I'm gonna put it in this kind of picture, and I'm gonna copy this. Okay, and let's put it right here. Okay, now, and what we know so far is this is A, and this is A. And we'll call this D1, and this thing D2. How about that? Good. And from the definition, we say D1 minus D2 has to be, absolute value while you're at it, right? Because it could be the other side too. Absolute value gives you plus or minus. You know what I'm saying? Has to be 2A. How about that? Okay, now, then let's give a coordinate. So this thingy is C, comma 0. The other focus is negative C, comma 0. What that tells you is this distance right here is C. You know what I'm saying? So A is always from the focus to the vertex. And C is always, oh, I got that wrong. A is always from the center to the vertex. And C is always from the center to the focus. You get it? And in this case, A is shorter than C. In case of ellipse we had yesterday, let's talk about this, right? This is C, and this was A, right? Center to the vertex, center to the focus. In this case, C is shorter than A. You know what I'm saying? Okay, so this is where we start. So D1 square root of, labeling this X and Y, of course. So X minus C squared plus Y minus 0 squared minus square root of X minus negative C squared plus Y squared. And then we'll say is equal to plus or minus 2A. How about that? Because we're going to square both sides. Plus or minus. Remember the absolute value gives you plus or minus A. Okay, now I'm going to scroll. Now we have to send one of them to the other side. So let's send the negative one to the other side. Then we have this. So far so good. Now we square both sides and square these thingies inside. And this is a term that is crazy. Just barely fitted it. So far with me? Okay, let's cancel a few things. X squared cancels that thingy, Y squared cancels that thingy, C squared cancels that C squared. I think we canceled everything. Okay, I'm gonna bring something to one side and something else to the other side. Okay, so it looks like 2cx. I'm gonna do it this way. 4a is there, so let's do it this way. Plus or minus 4a square root of x minus c squared plus y squared is equal to, I'm gonna go the other way. You know what? I'm gonna go the other way. The other way makes more sense. So negative 4cx minus 4a squared is equal to plus or minus 4a square root of x minus c squared plus y squared. So far with me? Say yes. Now I'm going to, before I square both sides, I'm going to divide both sides by negative 4a. Okay? I think I made a mistake.
Isn't it x plus c squared?
X plus c, yeah, I made a mistake. This is plus, right? There is more mistake. I know this is not right. Something doesn't feel right. I can't find it at the moment. D1, oh yeah. Here's my mistake. D1 is this one on the left, right? So this should be plus. And the other one should be minus. You know what I'm saying? The way I drawn up in the picture. So this is minus. You guys all got that mistake? Because in the picture here, D1 is the longer one with the negative C here. You get it? Okay. See, that was what's wrong with it. Okay. And somehow it changed the color. So this doesn't matter. This is plus. Change back to black. This was plus and this becomes minus. And this thing goes back to minus. Y'all with me? And then when I do this, this turns out to be like that. This is minus. Sorry about the confusion. Y'all get it? Questions? Okay then, continue. Divide both sides by 4a. So I have c over ax minus a is equal to plus or minus square root of x plus c squared plus y squared. Now you're wondering, how do you know which one to move where? Because yesterday I had on the left hand side, this side, something like a minus c thingy. Now I have c minus a thingy. And the way I know is, other than from the experience, remember here, c is longer than a. So I want to have a positive number here. I mean, it doesn't matter when you square both sides, but still. And yesterday, a is longer than c. That was my motivation, okay? Now, then I'm going to square both sides. So this will be c squared over a squared, x squared, minus, somebody tell me what that cross term is? I'm going to work on the other side until you figure out this thingy in the middle. And x squared plus 2cx plus c squared plus y squared. What do you have? Oh, come on, it's not too much algebra.
2cx.
2cx is correct, right? Y'all got it? This was still minus. Ah, so many mistakes, right? The other side is minus. Okay. And then this thingy cancels that thingy. You see it? Okay, now, then I collect the like terms. So I'm gonna have a squared minus c squared. Once again, this is a positive number. Now it matters. Right, the other way, c is greater. So I'm gonna have c squared minus a squared here. Right, because geometrically from the picture, c is greater than a, so I want to have a positive number, difference of squares, and then I'm going to have c squared over a squared x squared minus x squared, notice that space right there, and then minus y squared. So far with me? Common denominator A? I feel a little ridiculous doing this for you, but hey. So I have c squared minus a squared over a squared x squared minus y squared is equal to c squared minus a squared. Stay with me. Divide both sides by c squared minus a squared. So I have x squared over c squared minus a squared minus y squared over c squared minus... why am I screwing up so much today? This was a squared. How about that? Too much algebra? I will wait for you to catch up. Finally, we let b squared to be c squared minus a squared. Then what we have is you get it? Now, let's just, I'm gonna go make a copy of the picture. I'm gonna make this copy of this thing, but get rid of this thingy and put it right here. Oh, that's tiny. Okay, now it's about the same size. Okay, now the key is here, this right triangle. See, the other way of saying this is, of course, is a squared plus b squared is equal to c squared. That sure looks like Pythagorean theorem, right? Ah, and then turns out, remember this length is a, and then this is b, and that happens to be c. So that length swings down as exactly same as this length. But why? I mean, other than looking at the picture created by the computer saying, okay, that's what it is, but why? And the other thing is, 2 years ago, when you're learning how to sketch this, remember you have to put this rectangle here and then, right? Why do we put that rectangle there? This is why. Let's try to figure out the asymptote, which is end behavior function last year, right? So if we do this for large x and y, like large x and y, meaning the difference of the two is only one, mere one. One is tiny difference. So if x gets big, y has to get big as well. You know what I'm saying? So for large x and y, this thingy is approximately 0. It's tiny once you zoom out quite far. So for so good, end behavior meaning x and y approaching infinity, or x approaching infinity. That tells you x squared over a squared is approximately equal to y squared over b squared, eh? I'm gonna square root both sides, so x over a is approximately y over b. Find my mistake? Plus or minus, kids. So y is approximately equal to plus or minus b over a x. Good. And this is the equation of asymptotes. My God, huh? Now, let's go back to the picture. Since asymptotes are the part of the graph and your slope is b over a, negative b over a, and we have to draw it on. So it's so much better if you just draw the whole rectangle and draw these, then you know you can draw these asymptotes perfectly. You get it? Now, the term conic section. Why is it called conic section? When you sect something, what does it mean? What does it mean to sect? Oh boy, okay. Bisection, what does that mean?
To slice through.
Yeah, slice through, it cuts, right? Okay, so let me give you the equation of a cone. And then like teachers have this like stupid little wooden block cone, and then like that's not what it means, okay? This class you get to actually eventually will feel all of this, but for now you're gonna have to trust me. Plus y squared. Oh, looks like circle so far, right? No, 3D graph. Ready? This is a cone. Oh, that color is not good. What color does it show? Nicely. Okay, so this is a cone, double cone. Okay, so it happens. Now, having said that, I'm gonna cut this with a plane, okay? Okay, first I'm gonna cut it into this z is equal to 1. Okay, that plane. What color do you want this plane to be? Checkers. You see checkers cutting? Can you imagine what the cross section will look like? There, how about that? Circle, you get it? But that's not just a pure geometry cutting it, right? No. If you try substituting z1 into z here, then you get equation of the circle with a radius 1. You get it? You feel it? That's what it is. We get the equation of the circle by, see, when you say intersection, meaning that's always the systems of equation, isn't it? Remember the two intersections of the line, that intersection is a coordinate points and you calculate that, same idea. Intersection is always systems of equation we eliminate. Okay, then I'm going to tilt this plane a little bit, okay? So what that looks like. Okay, you see, plane is cutting right there parallel to this one of the edge. Imagine what that cross section is. Ah, it's a parabola. Amazing, isn't it? Okay, I'm gonna make it not as tilted. I'm gonna do this to increase the drama. I'm gonna shallow out that plane a little bit. See, slope is 1/2. Ready? Can you imagine it? Yeah, it's an ellipse. Now, can you see if you actually substitute these things in here and eliminate, then you see this will turn out to be ellipse? Oh, you better. Okay. Well, then finally, I'm gonna make this thing vertical. So, see, remember in case of parabola, this was parallel, now it's shallower, but now it's steeper. Well, that doesn't do anything. Well, I'm gonna zoom out now. Oh, you see hyperbola, right? There and there. And further, if I flip it around to the other side, these edges of the cone, oh, it's supposed to connect right here. There's a limitation of this program. Those are your asymptotes. Wow. And further, do you remember Degenerate Conics? Sometimes this thing, you know, does not give you regular conic, but like intersecting lines, things like that. This is a degenerate conic. If you cut it exactly to the middle, and then it gives you an X, and really no curve. Wow, 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 wow. How about that? That is conics section. Questions?